Okay, friends, let's get started. Last class, I was explaining about how to, I was explaining about how to read Excel files, right? And how to read CSV files and how uh, you can import or export uh, into CSV files. That's what we have seen last class. In today's class, we will see how to apply those, whatever we have learned in last class, into a real life linear regression problem, right? In today's class, I remember we haven't covered linear regression depth for your batch. So I thought to cover linear regression because for any uh, interview, you will be asked the question for linear regression. So the problem I have taken is given an AA model, right? What would be the training time for a specific data set size? As you know, the more, for example, if you want to do video processing, say, right? If your video, imagine it's your marriage video, right? If your marriage video is 1 hour, right? And then if I give it to, let's say, Adobe Premiere Pro or whatever software available, whatever software available, what will happen is it will take, if it is 1 hour time, it may take some 20 minutes, right? Say, for example, you have shooted for half a day, then it will be 2 hours, let's say. It may be 40 minutes, right? Imagine you have shooted for 2 days, let's say it's 4 hours, right? The processing time for creating the final video, I'm talking about final video, this is what you have taken on your mobile phone or professional camera. Nowadays, they have what they call the camera, yeah, so moving camera and so on, right? Forget the name, right? Let's say 80 minutes it takes, right, to process this video, right? If you go ask the cameraman, he will say, "Sir, we have shooted for 2 days, and hence we have 4 hour content, sir. We need at least 80 minutes, right?" So that's what he says, right? So he knows this time frame, right? Suppose if somebody, your new friend, comes in and he shoots for, let's say, 2 hour 45 minutes, right? We want to know how many. If this is my video size, how many time it will take to process it, right? So we cannot say if it is 3 hours, then we can say it's 60 minutes, right? What is 2 hour 25 minutes, right? Or let's say 2 hour 15 minutes, right? So we need some calculation, right? This we can make it as a linear regression problem, right? As you know, linear regression problem, we will we will study whether there is a relationship between these 2 points. I'm just showing it as a heart, right? Like imagine you and your family member, there is some relationship, right? Likewise, in a linear regression, we study the relationship between two data features, right? So in this case, instead of that video recording and the processing time, they have taken a model training time, the data set size, right? Here they say A model, it may be ML model also, right? ML is also an EA model, right? So it's an ML model. We have studied the random forest, decision trees, and so on. We want to know, imagine you are the boss, right? Let's delete this and then come with the new analogy to this thing. Imagine you are the boss, right? Under you, one data scientist guy is working, and you are saying, you are giving on day one, let's say, you are giving on day one, the data set size, let's say it's 10,000, right? 10,000 records you are giving. And for him to train it he takes some 5 minutes to train, right? By his model, right? On day two, you give some 20, right? His ML model takes 7 minutes. This is in minutes, and this is in thousands, right? This I write in thousands. Even though I say 10, it's not just 10 records. I'm talking about in thousands, right? Likewise, day three, you give 30, and it gives some 10. He took 10 minutes, right? So he has a chart, right? Say, for example, on a fine day, you come and say, tell me what is the training time it takes for 25 minutes, right? 25,000, right? So you don't need to run the model, right? Or let's say 125,000, 1,35,000 data size, right? Records, right? How much time it will take, right? Your boss is saying, hey, every day you are running. Can't you calculate, right? So for that, you say, boss, wait, I have a model. With that model, I can come up with this training time, right? That's our topic for today, right? That's what we are going to see. How can you solve this problem, right? The model says you cannot experiment again and again. For some small 10,000, 20,000, within an hour you can say, right? But if it is more than an hour, then you don't have time, right? If you execute this model, then your whole server will take time, right? Nowadays they use cloud computing. That's a different scenario. But I'm saying like how to compute, how to find out for a new data set size. How can I find this, right? This is a linear regression problem, right? How it is, we'll see, right? So this is it is given a training time. We want to find out the training time for a given data set size, right? So already I have explained this. So in this case, the same thing what we have discussed earlier. 10,000 data set size, 10 minutes is 12 minutes, right? 30,000, 33 minutes training time, it's right? 15,000, 55 minutes it takes, right? So the first one is called the first one, this is called, they call it as X, and this they call it as Y. Usually in mathematical formula, Y equal to some X, right? In a linear regression, the coefficients are M, X plus C, right? Right, so this is a Y, what is this Y? Training time. So I can write training time is equal to M into what is X? Data set size. So I'll say data set, say DS, right? Plus C, right? So to compute 135 training time, if I know the data, sorry, to compute the training time, yeah, I know the data set size is 135, right? But I don't know what is the M and C. This M and C is what we are going to compute through our model. So with that understanding, friends, let's get into the topic. So as I said, this is my independent variable, right? This is for the, I don't need to do anything. It is not dependent on any column, right? So it's independent variable, or it's called feature or a column. This is my resultant variable. This is what I want to know, training time, right? This is a dependent variable because to calculate training time, I need this data set size, right? In this table, we have only one column, and that one column data set size, I need it, right? Sometimes there may be two columns also, right? Data set size or the machine configuration, let's say, right? That also depends, right? So, but in this case, we have only one X. There may be multiple X, X1, X2, X3, and so on, right? So this is what it is, friends. So data set size is the independent variable, which is my input, and the training time is my dependent variable, which is the output. So your boss is asking, tell me for 35,000 samples, right? I asked for 1,25,000 samples, but your boss very kind to you, asking for 35,000 samples. And also for 70,000 samples, 2 questions he's asking, right? So you will say, boss, wait, let me finish this class and tell you, right? So now, before we proceed any problem, we want to see this I have told you. This is the equation for straight line, y equal to mx plus c, right? We have already written this. I'm just going to, in this case, m is my slope, right? So if this is my line, right, my slope is this, right? If I know the slope, this is called the slope m. If I know this value, right, then I can, using this slope, I can calculate m. Actually, this is the slope, right? If I know the slope, like climbing the ladder, you have that, what is that, climbing ladder or whatever it may be, right? In parks, they have, right, that sliding thing. That sliding ladder is called a slope, right? So if I know this slope, and if I know this intercept, this y-intercept is nothing but this point, where my regression line intersects, right? This is my, so in other words, here, what will be the value? X will be 0. Y, let's say this is, y starts from 10, 20, 30, and y may be 40, right? So in this case, 0, 40 is 1 second. Sorry about that, friends. So you understand what I'm trying to say now? This 40 is my y value, where the day when x is 0, where it is intersecting, that's called my y-intercept, right? That's what we say as v here, right? So hope up to this point it is clear. If you have questions, you can ask me. So this formula, you know, from the very beginning, you have studied in log towards y equal to mx plus b. That's what I will explain, right? This is m model coefficient is my slope and b is my model intercept. So why do we solve this problem? You can ask me honestly, sir. There are so many problems to explain linear regressions, sir. Why do you take this? Because this is very important. Estimating the training time is very important because it will help us to estimate the training cost, right? And if I know like this much time is required, then I know what resources I need right up front. And also, I know what machines I have to rent from AWS or Microsoft Azure or Google Computer platform, right? That those cloud computing, right? I can also know whether I can run my code on the free Colab thing, or I have to use my credit card to hire a new machine on Google Colab Pro, right? I can say, like 10 years ago, I was using Google Colab. At that time, there were not many, I think at the time only they have introduced Google Colab, I believe, at least 10 years or 8 years ago, I believe. So during that time, probably, yeah, 8 years or something. Yeah. So when we used, it was not a steady system, Google Chrome. Sometimes it may disconnect and so on. Right? It was on a trial mode kind of thing. So I remember I ran one model for 2 days even, right? Because we had a limited, with the free resource, we have to load it and save the model and again rerun it, and it took many hours. And after that, there come so many companies where you can pay and then get at a reasonable price, you can run your model, right? So, because I was exploring deep learning and all these neural networks, so my cloud computing budget was less. So it helps us to evaluate the cloud computing budget, right? So I cannot tell to my, for example, if I want to go from here to some 10 kilometers from your place, within 10 kilometers, there is no use for you to run and get a taxi, right? For that, you can get a Ola or Uber or whatever your services available, or Rapido, right? But if you are going from one state to another state, then you have to think of renting a separate private taxi. So that kind of scenario it is. So with that, let's say get into our model. I'm importing some of the libraries. So here I'm having a CSV file. Last class I've explained you about CSV files, and then I've explained read CSV also, like what it is. In this case, I have uploaded a training CSV file, right? And then I'm using the I'm displaying the data set. So as you can see here, this is my past record, right? As if I'm the data set, data scientist. On day which is 0, it took me for 10,000 records. It took me 12 minutes. Day 1 took me 22 minutes. Likewise, day 8 it took me 98 minutes, right? Likewise, right? So this is what it is. As I have calculated and I stored it, and then I'm giving it to my model, right? And then I'm trying to plot it, this data set size, and then training time. I plot it as a scatter plot. When it plot, to my amazement, the lines are when I connect these lines, I get kind of a straight line. Sorry, I am drawing like it's not. I'm not drawing a straight line, but it is actually with a straight line we can cover this all these points, right? So that's the idea between a linear regression. So as you can see here, we have all this scatter plot, that's what we do. And then as you know, once you give the data set, imagine you have let's say you have some 1, 2, 3, 4, 5, 6, 7. In this is my y, right? Let's say y equal to mx1 plus something, x1 plus x2 plus kind of thing that I'm talking about, right? So that is so that is my y, right? So this is my output, in other words, or my target, right? And they call it as the target here. And these are my available features. I can use any of these. For example, name, age, and for example, so many things. And one of the feature is training time. Let's say T is my training time. And also I have the configuration of my computer, like which company of that AWS or Azure or whatever it may be, right? And some other field, let's say X field, right? So out of all these features, which is going to help me in determining this output? What is my output? Training time, right? For this training time, definitely I don't need the name, right? So I'm going to strike it out. I also don't need my age, but I need the training time. Sorry, the data set size, right? This is not T, but this is a D. right? Training time comes here, right? Why is my training time, right? How much time it will take, right? Let's say this is D, this is what I want. Let me change this so that you understand, right? So this is my data set size, and this is my training time, right? For training time only I want to calculate, right? For that, I'm going through each one variable. Oh, data set size, this is an important variable. So let's keep that, right? And then what is that? Which company it is, right? For me, company doesn't matter, right? Any for Ola, it doesn't matter which car you indicate. It doesn't matter. I mean, same within Ola, they have some standard charges, right? Like that kind of X, that variable also I don't want. So only I need a D data set size. Other things I can drop, right? But in our case, we have only two variables, namely the data set size and the training time, right, friends? So in this case, for this training time to calculate, I need only the data set size, right? This I will call it as a feature. So I'm going to create a column called a feature. And within the feature column, I'm going to use what are the related columns to calculate this training time. In this feature column, I'm going to store D separate because this is my input kind of thing. And T, I'll store it as a target, right? Or the output, right? So this is what they're doing. Target DF the training time. Features DF, drop the training time. So if I drop the training time, right, I will get only this column alone, data set only, right? Because only two columns are there. That I use it as a feature. That's what it is. So now we use this linear model. We have already seen this linear model, and within the linear model, we have this linear regression class, right? So using this class, I'm creating an object, right, called a reg, and that using in that regression object, I have a model called a fit. This method I use within that I'm giving the x and y, right? This we know a fit method where we train all the values to get the model. Right? So now we have this linear regression model, right? And now we can what we do what we can do is now we can predict, right? So apart from that 9 values, 1, 2, 3, 9, I'm giving some new value, let's say 33. I'm asking for 33,000. It's in thousand, right? What would be the training time, right? So for that, I am giving the predict within bracket 3. Let's say it says 36.3, right? That's what it is saying, right? So this coefficient, if you remember, this is nothing but my slope, right? And intercept is my B and right? So as you can see here. So using the formula y equal to mx plus c, I can apply this coefficient m and then b, right? And then we can calculate whether the model is predicted correctly or not. To my suggestion and to my guess, this is not the right value. It must be around 34 or 33, 34 it seems, right? But how will I know it is correct or wrong, right? For that, instead of checking with one point like 33 alone, I can also check with multiple points, right? I'll give, tell me for 15, tell me for 35, tell me for 35, and all those things. So if you remember, they are giving it as a CSV file, right? This is the question paper kind of a thing. For this question paper, I need answer, right? So that's what we are doing it here, right? So for this question paper, I got the answer. Since there are three questions for 15, 25, 35, I got the answer as 16.6, 27.6, 38.5. Right. So the way we did is regression.predict. Earlier we used fit to train the model. Predict is for predicting. In this case, I'm passing a CSV file. Which were converted to data frame, and the data frame I'm passing. So next, I have this predicted times now. I already have the question. In that question, I have to write the answer now. For that, I'm writing this answer. What is this answer? The 16.6, the 37, 38.5. I want to answer it in the same line, right? So for that, I'm adding this predicted training time onto my data set size, the VF, right? So now, earlier it was having only the question. Now it has both the question and answer, right, friends? So if you want to send it to the client, you can send it as a data frame. Hey, client, this is my answer. I'll copy and paste it. I'm author. I have it, right? So this will be for just three, but not give three and all. You will give three lakh data set, and then you will ask 3 lakh combination, or at least some 30 combinations, right? But 30 different data sets. He will ask you to compute the training time, right? So that you will know. For say, for example, for North America, we have one data set size. For Asia specific, he has one data set. For Africa, he has one data set like that, right? Right. So this is what it is, right? So now because of that, since it's we have to convert this, we can save it as a file, like a CSV file, which we have discussed last class, right? If you have attended the last class, then fine. If not, look at the recording. We have a function called true underscore CSV. In that, we can say specify the file name, and then we can also say index is equal to false. So now it has this result has been saved as what result? This result as a file. Let's check that. Yeah, so we, as you can see here, friends, we have the answers, right? It is stored as a CSV file, and this you can attach in a mail and you can send it to the respective groups. Next is we want to check like how good is our model design, right? So in that case, another way we can do is we can let's say this is my data set, right? The original data set I'm just going to show. This is my original data set, right? So in this original data set, I'm just going to say you strike out all these values, right? And I'm just going to input this as my input to my new model. And I'm going to ask the model to predict what would be the time taken for 10, right? For 10, let's say it says 11. Likewise, it will say for all the things. Let's say for 70, it says 77, right? So, but after the system predicts for all the 10, and then I'll say, I'll compare it with my actual thing. So I found it that it was actually 12 minutes, but the model has predicted is 11. So the difference is now 12 minus 1, which is 1 minute, right? Likewise, it was 78. It has predicted, 77, 78 actually. So actually, it's 78 only, correct? 78 minus 7 is equal to 1, right? So this becomes my error, right? Whatever I explained you, what they're doing it here. So here on the data set size, on the original data frame, right? Data set, which is my input data set. I'm just taking data set size alone, and then I'm trying to predict it. I'm plotting that the predicted result as a green dot, right? And the result which is already on the table, right, which is the actual one, I represent it as the blue point, right? Then I look at it, and then like how your professor give answers, like that I will say, first question you have written right. Second question, since it's a max exam, I will say wrong. I will not say this closer. This is also you have said right. This is also you have predicted wrong. This is also wrong. This is right. This is wrong. This is right. This is right. Let's say out of 10, 1, 2, 3, 4 wrongs are there, right? So I'll put a score 10 out of 10. You have said a 6, right? Correct, right? So this is what we will infer from this table. All right. Likewise, in Python, you can also put a straight line. This line is called a regression line, this blue line. And this line is my actual this is my actual prediction line, right? So And also, instead of using that matplotlib and so on, we also have another class called prediction error display, right? In that, we can use uh, to plot it, right, from the predictions, and it also gives the similar kind of a result. So the only difference is earlier we used this diagram is for training time versus data set size, right? But this is actually actual versus predicted value, right? And you can see the x-axis labels are same: 11.2, 11.2, 10.2, 10.2. Right? So we have different evaluation metrics to evaluate our regression model. Right? The first one is called, we will go from mean square error. Square error is very simple things. Mean square error is nothing but we will calculate the actual minus predicted, and then we'll do it for all the points, and then we'll divide it by number of points, which is my average, right? Which will gives me the average. And I also put a square by making sure that, for example, if I get for 10, I get, let's say, 11. For 100, I get some 1 lakh, let's say, right? In this case, the actual and the predicted are two, it's kind of really opposite, right? Whereas this is somewhat close, right? 10 and 11 is like you have missed only 1 minute, right? But instead of 100 minutes, if I say 1 lakh minutes, then it's wrong, right? So, but this is what it does. Mean square error. Actually, if it is 100, then it will zoom it and then it will show it, right? Like mean square error, we also have root mean square error. Root mean square error is same as the mean square error. The only difference is we'll we'll put a root on top of it of this mean square error formula. And then like mathematics, we'll take out the square and square root. It will be returned to back to the original, right? So that's what it is, because 100 becomes what, 1 lakh kind of thing. If we give this, then it will be the same as what the time is. Like if it is 100, then it will be like 101 minutes and so on. Next, as I said, R square, which is a very important one. Right. So here we subtract 1 minus, which is this is called a sum of residuals, and this is I think I forget sum of a squared average or something, right? So in this case, as you can see here, uh, this is very helpful to do like this. Right? So mean absolute error is how far predictions are all on of an average, right? That's what it says. On an average, what is the error, right? Mean squared error is it's good for parallelizing the big errors, right? Likewise, the root mean squared error is for error in the same unit as the output, right? And R square is how much variation model explains, right? So I can calculate for our example. And we found like it is R square is 0.999 something because the model is really good, right? One is really good. As you can see, there is no bias, right? So in general, mean squared error is for calculating the absolute prediction error, and it is good when the error rate is smaller. Likewise, in other words, when they say when MEI is small, let's say 0.2, 0.1, then it's a good, then you can conclude that the model is good. Right? Mean squared error, it's good. It's not. So it is actually penalized large errors, like 100 means it will show it as 1 lakh kind of a scenario, right? Whereas RMLC is easier to interpret, and this is what we are planning to. So here we are drawing an heat map just to show this R square values, right? So as you can see here, 0.0 to 0.5, 0.0, this is probably 0, I believe. The blue one, normal blue are 0.0, and the reds are 0.5 kind of thing. So with this, I'll stop. To summarize, if you have any questions, you can ask me. You can type on the chat. So before that, to conclude, let's see this chart. So as you can see here, if it is mean square error, suppose this is what the actual result Y is, but predictor is this, right? So we can apply mean absolute error like this, right? We can take the model. And then average it to find out the mean absolute error. Likewise, on average predictions are 1.67 units. Right? So in this case, we are squaring it, right? This is what mean squared error is. So the larger the mistake, it will show more, right? It's not good. So in this case, we'll go for R square score, which will tell out which better the model is. Guessing near to 0.1, 1.0, the model explains 90% of the pattern in the actual data. With this, I'm going to stop it here, friends. To jump on the class. But if you have questions, you can type on the chat. If not, I really thank you. Hope the session was useful. Thank you, friends. Being on a Sunday evening, you have made it to attend on the peak time. Really, it will be helpful during your interview. Thank you, friends.
Recording stopped.